Welcome. So Gabriel is online. Gabriel Ho, from founder and CSO of ASAFA. I'm Fabrice Espinosa, founder and CEO of ASAFA. We have also two of our team members here, or one of our team members, Lynn, supporting us as well here. And of course, our two guests of the day, Cyril Schwab, that I will introduce very shortly, representing Airbus, and Faras Wibisono, representing Tripatra. So we will introduce them and give them the floor in a few minutes. Maybe before we give them the floor, a bit more information about some updates, let's say, about ASAFA. Okay. So first of all, for the one who doesn't know us, who are we? So we are leading Asia's Pacific SAF future together. We are the first and only non-profit, independent, neutral association promoting the adoption of SAF, sustainable aviation fuel, within Asia Pacific. We were launched 14 months ago in November 2024. And so since then, we have engaged with, as the industry, the whole ecosystem of SAF. We're not one single industry focused, but we're targeting the whole industry. We have engaged with policymakers. We have engaged with international and domestic organizations and associations to make sure that we approach and have the harmonized approach in terms of speaking about SAF in Asia Pacific. So our target, of course, policy convergence, policy capacity building, and regional ecosystem for Asia Pacific. Next slide, please, Gabriel. So the team has significantly grown compared to our launch. We are now a team of 10 people, 10 dedicated people supporting SAF in the region. Some of us are based, but most of us are based in Singapore, but we have people based in China, based in Germany as well. And we are coming from diverse backgrounds, diverse expertise, and diverse countries of birth, right? And I think that's what makes the ASAFA team a strong one, is that we bring different angles of the SAF ecosystem into the loop, whether it be from the finance side, from the legal side, from the technical side, from the biofuel side, from the aviation side, etc. And that's what we want to continue developing. And that's why we have also, and that's also not only representing the ASAFA team, but as well our members and partners that are from the whole ecosystem. So on the next slide, we want to share with you the latest updates in terms of members and partners. So there's been several. Recently, we had Tayo Oil, Platts, Standard & Poor's Global, and Idemitsu joining as a gold member. We also had Topso, Velocis, PAC, Apical, and we are missing, but Neste also is joining us as a silver member, and we have Sky Energy also, who was on SME tier, who is now promoting themselves into the silver tier. And last but not least, of course, we have Aether Fuel also, for the one that are based in Singapore or following the ecosystem evolution. They just announced a partnership with Aster to build pilot plants for fisher shops in Singapore, supported by Singapore government. All right, so it means that today we have 37 international members and partners, and stay tuned because we are going to announce more also in the coming weeks. We are just coming back from Thailand, Gabriel and I, and we will be able to announce more members and partners. So what we have done last year, since our launch, in 2025, we have spoken to more than 50 high-profile in-person industry events. So that includes 4 of our events, but that also includes more than 46 that are partners or events specialized in SAF, in aviation, in aviation finance, in biofuels, etc. But it means that we basically every week, one of ASAFA members was speaking into an event worldwide, but obviously most of them were focused in Asia Pacific. We have hosted also in our event more than 600 people, senior SAF stakeholders from governments, airlines, SAF producers, OEM, technology licensors, etc. The 4 events we had last year, the first one was in May in Singapore with Enterprise Singapore. We had also a second one in Bangkok and Tokyo. So our Innovation and Policy Summit in June. And the most recent one, the One Sky Policy Summit 2025, was hosted in November in Singapore with the support of the SAF Congress. And we will come back to this very quickly. 2025 was also the year for us to launch our first white paper, our inaugural paper published in November during COP30, so in Belém. We were there as well. It was APAC SAF Outlook 2025. It's a bit more than 100 pages. You can still download it on our website. It's free for everybody. And we're happy to get your feedback on that one. But we try to put all our heart in partnership with Argus Media. Coming back now to our One Sky Policy Summit. So the One Sky Policy Summit, it was our main event so far. Okay, we had 250 people attending for a full day at the Marina Bay Sands in Singapore. We hosted a representative from more than 12, but from 12 countries around the world: China, South Korea, ASEAN, Japan, Indonesia, Singapore, Australia, Thailand, Malaysia, Europe, France, and the UK. And we put most of them on stage to present to the public what were their strategy for SAF, meaning what were the current policies, what were the future policies, how do they see the market, and how do they want to support the implementation of SAF within the region. So now, having said that, what are the targets for us for 2026? We are going to have a certain number of additional events. We have already committed, and we will see that for Q2 events in Thailand and Japan. We're also looking at having some international and Innovation and Policy Summit IPS events in Malaysia, in Singapore, in China in Q3 of the year. One in Indonesia in Q4. We will also have our event in Xi'an with the Chinese IAGA, International Aviation Association for Green Aviation, so the Chinese SAF Association. We will have our One Sky Policy Summit 2026 in Q4 in November with SAF Congress in Singapore. We will have more publication as well. We will have launch working committees and training programs with our members and partners. And if we deep dive a bit more, then I want to focus, because that's not on this slide, but within the next few weeks, we're going to have also some events during the Singapore Air Show, or in parallel of the Singapore Air Show. We're going to have two events for the Singapore Air Show happening between the 3rd and the 6th of February 2028. We're going to have one event at the Air Show itself on Friday 6th morning between 10 a.m. and 12 p.m., focusing on feedstock, on SAF feedstock in Asia Pacific. And this event is supported by Airbus. And we're going to have another event as well, a site visit supported by Neste. We're going to visit the Neste Innovation Center on the 5th of February, on the Thursday, between 2 p.m. and 3 p.m. So that's two events. Please contact us if you are interested in joining. They are free events, but of course, for the Singapore Air Show ones, you need to access the Singapore Air Show. We will also have, with our partner Argus, we will also support them into organizing a dedicated day for SAF. First time ever, they're going to do that during the Argus Biofuel and Feedstock Asia Conference mid-April in Singapore. So we're going to be there to support them and organize the SAF Focus Day workshop on the 13th of April. Then we are mentioning it very quickly. Beginning of June, from the 3rd to the 5th of June, we will be in Tokyo for the second edition of the IPS Japan 2026. We are looking to organize this event with Act for Skies, the SAF Association of Japan. And at the end of this month, on the 24th and 26th of June, we will be in Bangkok for the IPS Thailand, second edition as well, organized in partnership with the Federation of Thai Industry Renewable Energy Industry Club. And before we move into our today's session, I would like also to introduce our next month's session in February, where we will hosted Erin from Jivo, and Jeff from Velocis, who spoke about SAF, obviously, which is, as you know, our favorite topic. Okay, that's about it for me. Thank you again for listening. We will now have our two dedicated speakers for today. First, to start will be Cyril Schwab from Airbus. Cyril is a SAF director for Asia Pacific. He has a long career working in innovation and technology at Airbus. Airbus, I'm not sure I need to introduce Airbus, but Airbus is the largest aeronautical and space company in Europe, providing products, services, and solutions from commercial aircraft, helicopters, defense, and space sectors. And of course, having this position, they are heavily involved in sustainable aviation and sustainable aviation fuel. Cyril, the floor is yours.
So I start again. Huh? I want to talk about this supply chain for sustainable fuel today. And I put as subtitles the invisible engine because we don't speak a lot about it, but you need it to actually have any SAF happening for us. Just a few, I'm trying to go to the next slide. I'm not going to bore you again on the overall scenario for net zero aviation, but you all know that SAF adoption is going to be key for this if we want to reach net zero. And you have many studies on what should be a SAF adoption scenario. I'm just putting one here, which is from our friends from ICF. And what you see is the volume that we are trying to reach. If we want to get net zero by 2050, depending on the scenario, you need between 300 million ton to 500 million ton of product that needs to be produced. And depending on the pathway we use, this means that we are talking about billion tons of materials that needs to be changed. This is interesting. What I want to highlight is the potential is here. It's not a scenario that has no chance of realizing. I'm reproducing it here, a study from IRENA from 2025, so quite recent, which was investigating the potential for SAF production in the region. And you see that just for ASEAN, we are already between 20 and 30 million tons of potential of production of SAF. Now there is a key word in what I'm saying and what I put on this slide, it's potential, because all of this is theoretical. And this is exactly what I want to talk about today. How do you go from theory to actual real volume of SAF? And so the feedstock potential is the base of it. We know we have it, but how do you move it to the real world? How do you bridge it to something that you can actually put in the plane? Like you need to organize orchestrate the supply chain, moving these volumes all over the place. And so this is what I put here in the middle. The physical supply chain needs to be here. And then, of course, you all work in the SAF space, so you know that cost is going to be critical. And so it's one thing to have a supply chain, but you need to have an optimized supply chain, something that is going to bring you the optimal price at the end of it, something that is cost competitive with existing energy solution. So I'm going to split the analysis of the supply chain in three parts. The one in the middle, the midstream conversion, this is what we talk a lot about, the technologies, the projects that we want to investigate. But what happens before and what happens after? What happens before is biomass upstream type of logistic. And so you need to collect it, you need to harvest it, you need to transport it, you need to pre-process it, and you need to transport it again to your refinery. Then you do the refinery, and then from the refinery, you still need to go to the plane. So you need to do the blending, you need to do the distribution, and you need to fill this in the plane. And all these elements are going to add up to the final cost for the end user. Starting with upstream, it's a very complex business. So I'm not going to explain everything today, but you have SAF is not the first bioenergy industry that is being set up. And so there is a lot of studies on what it is to take biomass and to transform it in energy. You have a bit of a view here on the right. I took from a report from the International Energy Agency. But basically, this is what I was saying before. You need to harvest your biomass. You need to transport it to some place where you can pre-treat it and make it convenient to produce your energy. And then you push it to the conversion side, refineries, before you can actually use it as an energy medium. There is two elements that are critical here and universal for any biomass to energy system. Number one, the price of the feedstock, a huge part of it is actually the transport. The cost of the biomass at the refinery gates, many studies looking into it, and they will tell you it's for anywhere between 40% to 100%, depending on the initial cost of the biomass. So it's already massive. Logistical cost is a massive part of the biomass supply chain. Number two, we are looking at processes which all have a yield that is not fantastic. You have transformation yield from biomass to energy that are between 10% to 50%. But most of the process we are looking at, they will be sitting at the 20, 30%. And so not only you need to move massive amount of biomass, with a huge logistical cost. But on top of it, you need to multiply this by 5 or 10 due to the low yield process that you're looking at, making the logistical cost in most of the business case we are looking at one of the biggest. The biomass logistical cost is one of the biggest element of the final cost of the product. So definitely something that needs to be looked into, to be set up from zero, because this logistic doesn't exist and needs to be optimized. An immediate consequence of this, again, I go back to one of my first comments when I was showing the potential of biomass. It's a potential unless you can realize it, until you can actually go and grab it and make it in an economical fashion. And so this is giving yield to something, giving rise to something that we call feasibility radius. So I apologize for the illustration. I did this with an AI, of course. So we have the US in the background, but it should be ASEAN or something more related to Asia Pacific. But this is taking into account two realities. Number one, the feedstock, they are not concentrated. They are spread all over the place in a geographical area, and it's thinly spread. So they are not a huge concentration, huge volume at the same place. You need to go and collect it on the field. There is no escaping this. Number two, you have a cost of logistics, meaning that you cannot go all over the place to realize it. And in the end, it's translated to this feasibility radius, limiting the amount of the feedstock that you can access for a given location for a refinery, for example. Now, if you take this concept and you try to apply it to optimizing possibly a supply chain in a country, you have this kind of conclusion. So here I'm showing you the result of a study in Germany, where some colleagues were looking at how to produce, so it's PTL, so they are looking at two feedstock here. It's hydrogen and CO2, but the same concept would apply for any biogenic type of sources. And so they locate where are the sources of feedstock. You have them in green and brownish color here. So you have it in the three maps. They look at where you're supposed to deliver it in the end. So these are the airports. And then they are looking at what is the optimal scenario, where should I position my refinery, and which size should be my refinery, depending on the size of the demand. And you have three scenarios here: a low demand, so they put it in proportion to the jet fuel demand in Germany, so it's 2% SAF, 4% SAF, or 8% SAF scenario. And what you see when you see the demand at the beginning, it's a low demand, so they do one refinery somewhere close to the feedstock location. And you have a central type of scenario, which we like, in particular in the petrochemical industry. They like this kind of setup where you can have one place where you do a gigantic refinery, where you have economies of scale. And then from there, you distribute your product to everybody that actually needs it. But what you see when you go and increase the demand, the scenario that is optimal is not increasing the scale of this initial refinery. What you see in the end is some sort of decentralized scenario with many refineries of various size, and the size of the refineries are linked not to the demand actually, but to the size of the feedstock available next to the refineries. And so this is a complex, the optimized supply chain in the end, it needs to be integrated with the local feedstock, the localization of the feedstock, and not so much with the demand. You see that the demand is actually has zero impact on the localization of the refinery. So it's an interesting study. Again, it's still theoretical. We can push this a bit more, but what I want to highlight next is if you're localizing your refinery based on the feedstock, it means that the feedstock availability is actually dictating the amount of product you can do and where you're going to do it. And usually it's leading us to have this kind of thinking. First, I'm going to locate where can I find some cheap waste biomass, for example. And initially, you will find some. You will find an area somewhere in Germany, for example, where they have a lot of waste biomass, and they need to dispose of it for various reasons, including sometimes environmental impact. So they're happy to see you coming and say, I'm going to take it for you. I'm going to make something out of it. So you have this cheap waste biomass. It's going to justify your large capital investment to produce a refinery next to this biomass, for example. And you base this large investment on a 10-year return type of investment or even more. And the business case only works if you have the required cheap biomass, including the cheap logistics that come with it and so on. So once you have this, you start to run your refinery, you create some value, the bioenergy that is coming out of it. And it's all of a sudden is giving some value to this waste. And this brings me to the next slide. What happened after that is the cheap waste biomass doesn't exist anymore. And it's a well-known phenomenon in the waste industry, where they call it the tragedy of commons. It's not only the waste industry. Every time you have like a public resources and not all the interest of the supply chain participants are aligned, but some people will try to take a rent out of it. And in this particular example, the owner of the biomass, now that they know that their product is providing some value somewhere, they have a bit of economical knowledge. They go to this. They know that the people who invested for a 10-year return, they have a marginal cost. If you increase your cost, you're going to get them to lose a bit of money, but not enough for them to close door. So the operation is still running. You're milking, if you want, the project itself. The project will survive. So you don't have, on the surface, everything is still working. But the consequence is nobody will reinvest in this type of business in the near future. And at the stage we are today with SAF, this is something we absolutely want to avoid, because we want to attract as much capital as we need to create something that doesn't exist yet. And so the more you have high profile failure or low economical return on projects, the less attractive is it going to be. It's going to be for other people to come and put some money in there. And so it's one of the key issues that we're going to see play in the supply chain. And there is not, we see it play already, kind of. I remember early in the 2010s where we were starting to look into this sustainable aviation fuel. At the time, we were calling it biofuel for aviation. UCO was like the ultimate solution to reduce the cost of these biofuels. And at the time, the logic was it's a waste with low economical value. People are going to give it to us happily for zero. It didn't last long. Everybody knows about the trend of the UCO price. This is my personal artistical view of it. So you see, don't look exactly at the price, but we know that today it's around the 1,000 plus mark USD per ton. In the early 2020s, it was around 800, and when I was starting in this business, it was around the 500 mark. And so, of course, not all of it is due to what I was explaining before. A part of it is due of people realizing the value it has and then increasing the premium on it. A part of it is just the initial issue and the radius of feasibility. You need to collect UCO. The further you need to go, the more expensive it is. So, of course, the price of collecting it is increasing. But it's a mix between the two. Harder to collect plus opportunity to create some value. The second issue that you will see with this kind of things is you're putting more value on waste. You're incentivizing a bit of a fraud behavior, and we see it for UCO. The moment UCO start to reach a price where it's more expensive than the virgin oil price, of course, people start to have some ideas on how to make leverage of it and make more money from the virgin price. How can we avoid this? This is what I put here in green and big, regulation. And then, because I'm an optimistic guy, I put self-regulation. Of course, the more education you do, the more people are aligned and want to save the planet, the more they will try to play by the rules and be compliant. Try to they will put some oil in the gear to make it happen. But most likely, what's going to be necessary is what you have here in the middle is some sort of government regulation where you introduce quotas, tax, you regulate what you can do with the waste, you regulate the price that the waste is supposed to have so that you limit the bad behaviors that can come with it. And so there is no escaping this, and it's going to be a key element of what needs to happen in the coming years. That was for the upstream. So not too much detail, but you start to feel the problem that we need to unlock. And again, summarize in two main issues: the logistics, the distance, how to get the feedstock, and number two, how to optimize this one and optimize the behavior, organize the logistics, the supply chain around it, and regulate the behavior of the actors of the supply chain. Now, it's one thing to collect the biomass and to convert it in SAF. You still need to deliver it in the plane, right? It needs to go to the plane, to the airport. And so there is a bit of work that is done on the downstream supply chain. And for this one, I'm going to be way more optimistic than for the upstream. And the reason behind it is we, as an industry, are working on something that is trying to work to optimize this downstream supply chain, which is called book and claim. Basically dematerializing the final part of the supply chain. And why I am very optimistic is you just need to look on another part of the planet in Brazil, but today I'm in Indonesia, and I'm still making some parallel between Brazil and Indonesia. Both countries very massive, very big. And both countries, they have some islands. Right? So the islands in Indonesia, they are separated by water. The island in Brazil, they are separated by dense forests that you cannot cross either. And in any case, what it's going to do is it's making the logistic a nightmare for everybody, right? For both countries. And so it's very interesting to see that Brazil, who has their own mandate for sustainable fuels, they call it the fuel of the future law. And part of it, they are already mentioning that book and claim needs to be considered to satisfy the mandate. So very optimistic. And then not only it's mentioned, but there is some studies that come with it. I'm putting here a snapshot of a study that we did with RSB on the book and claim practical guide. How is it supposed to do? Because not only the infrastructure, the digital one to allow this need to be in place, but you need people to be able to use it. So I'm just putting another element that is making me extremely optimistic on this one, and you will recognize I'm a bit biased on this one because it's an initiative from Airbus. Huh? But ourselves, we've been working a lot on developing a bit of a demonstrator for using book and claim. I'm not going to detail every single thing of this demonstration, but the most interesting part is targeting all the end users that you can imagine that would need to use a book and claim. And the further you go from the aviation industry, the smaller the players are, the less proficient they will be in manipulating these kind of things. And so at some point you need facilitation. And so this was the art of what we've been working on with RSB, creating this facilitation type of role in the book and claim system. So you have people who are allowed to help you put some oil in the gear and make the thing happen. And so this is what we've done with RSB. We've onboarded, I'm putting you one slide very quickly, a few very interesting early adopters, some of them from the corporate world, some of them from the smaller jet operators, and so on and so. All of them interested and proving the point that you have some people who actually need some support in this. I'm putting a final slide to summarize again how optimistic I am on this one. So global momentum, which I see in 2026 for book and claim adoption and dematerializing this downstream logistic issue. Number one, even big voluntary framework for reporting of carbon emission like SBTi are starting to open the door to considering book and claim as an acceptable mean of demonstrating your reduction of emission. It's very positive. Number two, Brazil have detailed it already, but having a country this size with a mandate starting to recognize that you can use book and claim to satisfy your demand is extremely positive also. Number three, what I was showing from Airbus, but not only Airbus, very prominent actors from the industry ecosystem like IATA or regulators like ICAO are working on global standards and demonstration, because it's one of the issues today with book and claim is there are too many of them. So how do you select the registry you want to use? How do you make sure you're using the one you're supposed to use? So this, it's something that is happening, including the initiative that Airbus has been pushing. And I will finish with number four. A lot of things have been said on the European mandate and RefuelEU, but there is still some flexibility that is allowed in this one, especially during a transition period where basically they have like a giant mass and balance system, if you want, where there is, if you don't satisfy your obligation in one airport, you can compensate at another airport, which in some sense is a premise of a book and claim mechanism, at least at the European level, and a lot of discussion on understanding book and claim and how it should be integrated. So even in the place where you are expecting the least flexibility, like in Europe, you actually see a lot of it, and you see some positive momentum for book and claim mechanism. So this brings me to my conclusion slide, but basically I've tried to show you two things. Number one, if we want to scale the SAF supply chain and go from a potential to reality, at some point we need to move materials. So the supply chain, we need to look into it. We need to understand exactly how to optimize it, and we need to make it happen. And today it doesn't exist. So the sky is the limit, as we say. It's both negative and positive. It doesn't exist, so it's more expensive at the beginning, but we can start from scratch, so we can make an optimized one immediately. There is a positive momentum for the downstream part of the supply chain on this concept of book and claim. A lot of adoption, a lot of activities that is running through it. It's extremely positive. So I put it in green. I would like it to be flashing to you, and you remember this. It's positive. It's going to happen. You should start to take it into account in your business case if you do business case. The second point is on the upstream supply chain. It's more complicated. It's a tough system to optimize, but the logistic of the feedstock is the one on which we need to put most of our effort today. And so I would encourage everybody to try to think about it, especially if you're developing a SAF project. Look into the feedstock with a lot of attention. And then final point, I touch upon it very quickly for this tragedy of common story. Policies from the government is going to be needed when we talk about feedstock logistics is going to be critical. This would be my final word. Policies is critical. I think it's fitting for ASAFA, since you guys are here to influence policies.
It does completely. And thank you, Cyril, for those highlights. No wonder why Airbus is also supporting and joining ASAFA and is supporting ASAFA and vice versa. I mean, we are also fully aligned on the book and claim approach and concept, and we believe we need this at the regional scale in Asia Pacific at minimum, if not globally, but at least we need to develop something like this. And we are pushing also governments in the region to put in place some policies and to harmonize the ones that are existing, so that we create a common playground for the whole industry, for either the airlines, so the producers, the feedstock providers, etc., financiers. But so great, thanks very much, very interesting. We have some questions. So Gabriel, maybe you wanna look into the question, or I don't know if Cyril you can see the question. Questions, but
can you see it right now? First question: is there a special modeling software to use for the logistics planning? I think you show us a map, right? Or the studies. Is it some in-house knowledge? Or
I see a question on hydrogen. It's a very good question.
Okay, we can go to that too.
It's an exceptionally good question. I've been focusing
on
the the feedstock logistics, the supply chain is more complicated than just the feedstock. Hydrogen actually count as one feedstock. And so number one, where is the feedstock? Number two, you need to start to overlay the infrastructures that are available, in particular access to hydrogen. It's dictating a lot of localization of refineries today. But then you have two levels of it, where you can have aggregation of specific supply chain for feedstock, where you go all the way to aggregation, collection, aggregation, pre-treatment. And then localization of the refinery can be closer to hydrogen. And so both elements can be used at the same time when you're looking for the optimized scenario. Which one is going to be more heavy? I don't know, but refineries and actually collection centers, aggregation centers for biomass are two steps, if you want, in the supply chain. And in the end, you can optimize the localization of both independently. So I see this for the question of hydrogen. What is your opinion about green methanol? I like green methanol a lot. Methanol alone as an intermediate product can put more flexibility in the supply chain, because it's going to be easier to transport than biomass itself. So methanol is a fantastic tool to optimize supply chain as an intermediate product, even as a final product for the maritime industry on top of it.
For shipping industry, yeah. For the shipping industry, exactly. Yeah.
Oh, this was the two main questions I see in the chat. I don't know if there is more.
There's a few more.
There are
right?
more. There's one about book and claim. So would you project book and claim to eventually be accepted to help to fulfill mandate obligations?
But this was my message. I see it coming already in Brazil. I think that it will make sense for countries like Indonesia, for example, today I'm in Jakarta, to also adopt this kind of concept for sure. And I would push it even further, but this is just me dreaming. Book and claim, at least at regional level, one in Europe, one in ASEAN. It would be like the optimal solution for SAF distribution and for the end user.
Agree.
Yeah, this was
but yes, I would project book and claim to be accepted to fulfill mandate short to medium term.
I think there's some benefits for book and claim, at least within this region. Where
again, take this with a pinch of salt. I'm on the optimistic side of the things.
we have to. We are part of the optimistic side in SAF, right? But yeah, I think. And again, if you look at the Asian markets in general, not even beyond ASEAN, right, we see that we need to go beyond voluntary market, and we need to focus on the mandatory market as well. And that's why we believe that we need to make book and claim becoming also viable for the mandatory market.
Yes, because book and claim, I was heavy on the supply chain today, but not only it's here to facilitate the supply chain, it's also a key element on which to build to facilitate the voluntary market. So you can compound on top of it the benefits. I see a question.
And for traceability, it should be also somehow ultimately, if you do it properly, things properly, and then for traceability, it should be also a strength, so that you don't ship like everything all around the planet, right? I mean, you can have you ship the credits or which are recognized and certified by the right authorities or association. Okay, cool. Will adopting a more diverse, flexible supply chain help with advancing SAF adoption beyond only of taking from a few suppliers?
Maybe one more question. Yeah.
Maybe one last question.
From Dietmar. Why don't we consider developing smaller capacity SAF plants located closer to the feedstock sources? It all depends on the process that you're using. It's an optimization thing. Where at some point you have the scale effect fighting with the logistical effect. So you expect to have like a U curve at some point on the optimal size of the factory. And so it depends on the process that you're using, the yield that you have, and the cost of the logistic side feedstock. But in some scenario, I expect that smaller factories closer to feedstock will be the solution. In what I was showing for the Germany study before, it was what we saw, different size of refineries depending on the feedstock available around, and some of them were quite small.
Good.
Okay,
I
cool.
think we should, yeah, get on.
Thanks, Cyril. Yeah, Gabriel is
Thank
right.
you.
We
Pleasure.
should move forward because we won't have enough time for Faraz to introduce. And if stay with us, Cyril, if you don't mind, and if we have a bit of time at the end, we will cope with the latest question. But I'm sure Faraz will also have a lot of questions. So welcome, Faraz. Pleasure to see you first time in 2026. We met a lot in 2025, but pleasure to have you with us
Yes.
for 2026.
Nice to meet you again.
A quick introduction of you, my friend, and Tripatra as well. So you're the head of business development for green energy and chemical. You've been with Tripatra for certain years already, for quite a while. And Tripatra, for the one who are not familiar with this famous company in the region and beyond, Tripatra is an Indonesian engineering and construction firm with more than 50 years of experience in energy infrastructure and industrial projects. So they're kind of positioning themselves as a strategic partner in the energy transition, providing integrated engineering solutions with a focus on downstream development. So Cyril was talking a lot about downstream just recently, renewable and sustainability. So they are growing in the green business sector, developing R&D with academias, managing risk intelligently. So Faraz, please, floor is yours now. Happy to hear more about you and about what you guys are doing on a daily basis to support the adoption of SAF in the region. Thank you.
Yeah, thank you, Fabrice. Thank you, Gabriel, for introduction. So yes, my name is Faraz. I'm from Tripatra, a company from Indonesia. So I think just moving to the next slide for the short introduction about Tripatra. So we are the subsidiary of Indica Energy Group, a $3 billion revenue conglomerate in Indonesia. So Indica has several subsidiaries below them. They are doing the conventional business, also several renewable business. And we actually previously is the EPC company. So we are solely doing the EPC services for our client. And our specialization is on the oil and gas company. But I think a few years ago, I think starting from 2022, 2023, we are also going to the new also green energy development grid. So Tripatra in a glance that we are on 100% by Indica Energy, and they want to achieve net zero carbon by 2050. That's why we are doing this project development, specialized in a green energy, green chemical project to ensure that we can help our parent company to achieve that net zero carbon by 2050. We already have more than 50 years experience, as mentioned by Fabrice previously. We've done more than 100 projects across 6 priority sectors, multi-billions dollar project, and we have more than 1,000 of employees and also experts and engineers in our platform. So our business, we have 3 business units in Tripatra. So we have the ENC, the engineering and construction. This is our, we can say, the bread and butter, the core business of Tripatra. But starting from a few years ago, we also doing some diversification of our business, starting from the asset solution. So we are also doing the service for operation and maintenance. This is a service-based revenue to ensure that we have a more stable and more predictable revenue, while we also trying to start the development of our green energy projects. We are doing the investment, we are doing the development. So we are not only executing the engineering or construction of the project, but we also will be the shareholder of the project. So our first project is the sustainable aviation fuel, while we also have several other projects in our pipeline, such as the biomass to power, bioethanol, bio-based chemical, etc. So this is aligned with our vision to engineer sustainable solution that transform energy and accelerate downstream. So I think the general theme of Tripatra development is to leverage the strength of Indonesia, which is the palm industry. So we are trying to leverage the circular economy model of the palm industry, because we see that there are so many ways, so many byproduct stream that coming from the palm industry that's not yet utilized in a full optimized value. That's why we are trying to looking at these ways, looking at these byproducts to ensure that we can convert it towards a more high value product. So the first one is sustainable aviation fuel. This is coming from the UCO, used oil, and also palm oil mill as well, the one that will be discussed in more detail in this discussion. And we also have the biogas, biomass boiler, bioethanol, and also BioPG in our project pipeline. So what we are trying to do is not only to engineering the plan or maybe having a plan, but we are trying to develop an ecosystem in Indonesia. So we are doing an end-to-end solution starting from the feedstock supply. We will have a long-term supply contract and even trying to have the partnership with the feedstock supplier. And also from the off-taker, we are trying to get the long-term off-take from them also, from traders and also the airlines. Also, we will be the one that executing the EPC for our project. And we also already having a partnership with the technology license, which is the market leader in small to medium scale SAF technology. So I think going to the general concept or general thing that we want to discuss in this discussion is that the aviation net zero carbon target by 2050 is quite a big challenge for us to achieve together. And we see there are many ways to achieve the decarbonization for aviation industry, but we understand that the biggest part of it will be coming from the fuel. So 70% will be coming from the fuel. That's why SAF is the key for the aviation net zero target. And that's why the demand also rises rapidly. We see that the forecast show 19 million ton annual will be expected for the worldwide demand by 2030. But it's very difficult to achieve because we have a limited feedstock. So not necessarily limited players or limited cost, but it's directly coming from limited feedstock, also limited by the technology. And Indonesia obviously positioned very well because we have abundant waste oils. That's why we are potentially becoming the center of SAF industry in the world. So I think generally speaking that we are having so many types of feedstock in Indonesia. We are trying to separate into three categories. The one that doing HEFA technology, which is the waste oils, and maybe there are some that coming from biomass, which is can be converted using the alcohol to jet and also gasification fissile props. And maybe we can also leverage our energy sources to do the PTL, power to liquid. We see that maybe the PTL is still very difficult to achieve in Indonesia because obviously the energy sources in Indonesia still not really sustainable and also having a quite high cost. So we are trying to focus on the HEFA, ATG, and GFT. The total potential will be around 18 million ton per year in Indonesia using our local feedstock. But again, as I mentioned previously, that not all technology is currently already measured, not all technology is already commercially viable. That's why we see that the most promising one, the one that we can say the low-hanging fruit is the HEFA process, obviously, because it's already mature, both from technical perspective and also commercial perspective. While we can say it will be limited by the feedstock availability, but again, we are positioned very well to be the one that we can say have a big production coming from the HEFA production because we have the feedstock available in Indonesia. So in terms of the feedstock for producing SAF from HEFA pathway, we have several types of feedstock available in Indonesia. Palm oil effluent, obviously used cooking oil, PFAD, and also empty fruit juice oil. But again, there are several challenges that we see coming from this type of feedstock. If we are trying to see UCO, the infrastructure in Indonesia is still not yet mature, so it will still very limited in the volume itself. Also, we see that there will be a future shortage and also high price expected because of export pool and also informal markets, because we see that so many SAF production that already produced right now is relying on the UCO. That's why we see that there will be future shortage and also high price expected in the near future. And PFAD, again, we have abundance volume in Indonesia, but it's not yet eligible by RED III because it's considered as the product, not waste. That's why also this is something that quite limited in terms of the acceptance from the global market. Also EFB, this is also quite interesting, but again, it's a lower yields compared to POME, high moisture solids, and also it's quite logistics heavy because the moisture content is even more than 30%, 40%. That's why we are trying to focus on the POME because this is something that readily available and we can say in an abundantly available, but the challenge is how to ensure that we can convert this POME into a real life production. So general or short introduction, what is POME? So POME is generated from the milling process of palm oil fruits. So if we are trying to press the palm fruit, then we will get the oil. But again, if we are having the palm fruit before we press it, it will need to be steamed inside the sterilizer, and the sterilizer, the steam will will take some of the oils coming from the palm fruit. And also when they are trying to separate the water and also oil in the clarifier, there will be some of oil that coming with the water. That's why this residual oil that coming into the fat bed and also the cooling pond inside the waste treatment is considered as a palm oil mill effluent. So ICC itself already allows the amount of oil that coming from this POME, which is around 0.3 to 0.7% of the total mass of fresh fruit bunch. Obviously, the untreated POME will release methane, the potent greenhouse gases, so it will be a very, very excellent way to reduce the amount of greenhouse gases emission if we are able to capture the POME oil for SAF. That's why it's not only to produce the SAF, but it also reduce the emission in palm oil. Again, this presents opportunity and risk from the POME that produced from the palm oil mill. So obviously, the price is lower compared to the UCO. So we can have the competitive sale price, and also the additional margin can be invested for a greener facility. And obviously, it has a low emission value. It's free from the ILOC value because it is a waste, not a byproduct or maybe the product. And we can also coupling it with the biomethane hydrogen and also biomass power plant to reduce further the emission that coming from the SAF plant. And the third one is that the infrastructure is already ready to use also, because we are directly use the road and port that used for CPO business, and it can be also improved using the biofuel for road and sea transportation. But obviously, it's also having some risk. That's why we need to flip it into opportunity. The first one, obviously, it's scattered because the volume itself is quite small from 1 mil, because it's only 0.3 to 0.7% from the fresh fruit bunch press. That's why we need to ensure that we can match the plant capacity to the area potential, and we need to position the plant, locate the plant near the feedstock hotspot to reduce the difficulty in the logistic part. And it has also quite high impurities and also uneven specification, and we also discuss it later. So we need a robust state-of-the-art processing technology, future-proof plant design, and the last one, also the issue in the integrity and also traceability. So we need to ensure we have an end-to-end certified supply chain. And from Tripatra itself, we want to develop a blockchain-based traceability system to ensure the integrity and also traceability of the POME itself. So I can break it towards for pathway to ensure that we are able to unlock the POME oil's potential at SAF itself. The first one is the right scalability. The second one is robust pre-treatment. The third one is traceability X detector, and the last one is the global stamp of approval. So starting from the first one is the right scalability. So we need to ensure that we have the right scale plan, because POME is a waste. It's a natural waste. That's why we cannot intentionally pumping out the volume coming from the palm oil mill. It's already there, so we need to ensure that we have a right scale to build the SAF plant close to the location of the POME itself. So the feedstock security, it will matter most, because to meet the plant capacity, it will be ensured that we will need the required volume for our SAF plant. Also to ensure that we have a cost-effective logistic. Also the feedstock integrity, because the shorter supply lines will simplify the traceability process. And the last one, obviously, if we have the close location between the feedstock source and also the plant, it will reduce the LCA being lower, because it will reduce the amount of logistic required, and also we can also utilize the biomethane for our plant. Moving on to the next strategy is a robust pretreatment, because if we talk about the common UCO pretreatment that already done in several SAF plants right now, it will be not sufficient to pretreat the POME before it going to the SAF plant. That's why we need we can say a robust state-of-the-art pretreatment process to ensure that we will have a reliable, stable plant operation. Because pretreatment is the safeguard of the HEFA process. If the feedstock is not get the minimum requirement to be able to fit into the SAF plant, then it will be make the stability and the standard will not achieve, and the plant operational reliability may also fail. Because POME oil has some higher impurities, higher metal phosphorus level, high free fatty acid content, so we need the more acid resistant construction. And the last one is the inconsistent spec from sources, because it is a waste, so we cannot directly control the quality of the POME that coming from a different house. Moving on to the next one is the traceability architecture. So we need to ensure that we develop right monitoring, reporting, and verification system for the POME oil. So obviously, right now we already have the ICC certification, ICC CORSIA, and also ICCU. But we see from Tripatra perspective is that it's not really enough. So we need to ensure that we will have another layer of security, which is we are trying to develop the chain of custody system using a blockchain-based MRV system, and also to ensure that we have an incentive-aligned pricing. So in terms of the blockchain traceability system, so this is what we want to develop with our partners. So starting from plantation, mill, collection point, SAF plant, even to the end user, it will have exact token, so we can trace even each molecule, each gram of the feedstock that will be used as the feedstock for our SAF plant, where it's coming from, where the plantation is, where the mill is, etc. And this is also designed for EUDR compliance. So I think also just to give several details from the program that we are trying to develop with our partner, which is HARA. So they are trying to develop a national traceability platform to ensure that we will have event-based traceability. So it will be a real time simulation. So it will also help the value chain actors, which is the POME mills, the UCO collectors, the aggregators, to be able to provide the data required by the suppliers, the government agency, and also the certification bodies to ensure that they will have the traceability, ensure the integrity also from the feedstock. So this is the screenshot for the traceability platform. So it will be consist of the data required to ensure the traceability of the feedstock itself. So we will understand where it's coming from. There's a bill of landing. There will be each time the feedstock leaves the facility to the SAF plant, it will have one token, one blockchain token, and you can trace it directly if the SAF buyers requires this traceability requirement. And we also have the export node, so it's a very, very robust and also we can say a complete system. And this is what our partner proposed, that we will have a stakeholder architecture. We will be the one that implement the system, while HARA will be the one that do the technology digital backbone. And there will be the feedstock supplier that will be as an operational partner. Maybe later on we will have ASAFA on board also to align with global standard SAF markets, where we also trying to engage with the national private sector ecosystem mobilizer to ensure the national adoption and also industry engagement. And we also already trying to get this system into pilot design. So we will use it in like a few mills in our partnership, also with the UCO network. So we will understand what is the problem, if there's any issue and concern with the system. So we will trying to optimize everything before we are going for a commercial scale of this system. And also not necessarily coming from traceability process, but we are trying to do it from the commercial perspective. So we see that there is a concern from the EU, from the global market, that the POME is blended by CPO. So the simple thing that we do in our project to ensure the traceability is that we're trying to de-incentivize this mixing. So we use the POME cost is discount factor to the CPO. That's why it will be not commercially viable for the producer if the supplier, if they are trying to mix the CPO to the POME, because our price will be always lower than the CPO cost. Okay, and the last one is the global stamp of approval. So in the last year, 2025, we Tripatra together with IPOS and also the Ministry of Transportation of Indonesia is already proposed the LCA default value for POME oil that previously not there yet in the ICAO book. So why this is important? Because POME obviously is already on the positive list, but lacks of an LCA default value. So why this is important? Because it will provide a predictable GSC number, so it can be directly used for everyone using POME. So it will also cut the cost and also time compared to the custom-made project LCA. So we don't have to contract one consultant and they're trying to calculate the LCA for one project, so it can be universally used. So we already calculate together with the Hasselt University. So there are two cases. The Hasselt University calculation is Malaysian feedstock for European plant, while Indonesian team is Indonesian feedstock for Indonesian plant. So it already started from November 2024 and it already approved by November 2025. So we can say that it will help to de-risk the investment and unlock the first mover plan. Also, we already get the number, which is 18.1 gram CO2 equivalent per megajoule, which is around 79.6% reduction from the conventional jet fuel, which is far beyond the CORSIA and RED 3 required. And this is the step that we take in the last year. So we are doing the calculation from the raw data proposal. So the difference between our case and the hazard case is that we using Indonesia feedstock for Indonesia plant, while hazard using Malaysia feedstock to European plant, which is a higher transportation emission, obviously, because it has a transcontinental transportation. But comparing the electricity emission, because in Indonesia there is still a quite high use of coal, if we have a high electricity emission, it will be balancing the total LCA that will be calculated in the end. For the module itself, we are using the eco-invent because it's suitable for the rest of the world, while the hazard university using the grid that's suitable for US, UK, or EU cases. And we already get the number, as I mentioned previously, by November 2035. This is something that we can say a very, very big step for the POME-SAF production. So we hope that this achievement will help the POME-SAF projects that done in the region and also the Asia Pacific to be moving forward to achieve the FID and even to the commercial of operation. So in conclusion is that the POME-SAF implementation will play a key role in advancing global sustainable development goals, because obviously it will provide volume around 700, even 1,000 KTPA waste-based sustainable aviation fuel. Also, we already have the default POME-based fuel type cycle value. And it's also helped the environmental because it reduces the methane emission and improve the water and other conditions, deliver more than 79% lower life cycle emission. Obviously, it's also helped the economic growth in the region and also Asia Pacific. And the last one is to have the regional standard and resilience. And beyond the POME, we also have several in our pipeline, such as SBO, EFB oil, and also palm kernel expeller. This is 3 other feedstocks that currently we can say abundantly available in Indonesia. And we are trying to develop the LCA default value also, and maybe even going to the commercial operation and the building of the SAF plant that using this type of feedstock. I think that's all that we can present for today's discussion. If there's any question, please let me know. Thank you so much.
Thank you for that. Really wonderful. So much to unpack. And so many questions coming in. We'll try to take some of them. I think there were, of course, questions about even other feedstocks. But Boris, can you see some of the questions right now? Maybe this is display. First question is, since you mentioned that SAF will be vital in helping Indonesia meet its carbon neutral target, which SAF feedstock will play the most important role? Is it going to be CPO, UCO, or POME? Could you share your thoughts on this?
So obviously not CPO, I believe, because obviously CPO is an edible oils. It also having even higher LCA value compared to conventional jet fuel. That's why I think this is something that quite difficult to be developed even for the local consumption. That's why we see that the future will be both UCO and POME. But again, if we are trying to compare the UCO infrastructure and also the POME infrastructure, what we see in Indonesia currently is the POME infrastructure is more mature compared to UCO, because POME can directly use the CPO existing infrastructure, while the UCO, we need to develop the collection point, we need to have like the integrated logistic for the UCO. This is something that not really developed in a major position in Indonesia. That's why I think in the future, both UCO and POME is very vital, but the low-hanging fruit, or we can say the short-term target, mostly on the POME, while still using the available UCO in the market.
I think there's something to speak a lot about, that the waste collection, so-called businesses, industry needs more new capital, right, to make this happen at scale, because we were talking about millions and millions of tons. Also related one, the question is, what yield can we expect from POME as a feedstock, and how does it stack up against UCO? I'm sure it's a very technical question, but I can share as much as you want on this.
Sure. Sure, no, nothing. In terms of the yield, it depends on the technology that being used because every sensor has their own yield. But I think generally speaking, it's around 70 to 80% conversion for the yield of the POME. And if we compare to UCO, there will be a little bit balance because in terms of the MNI, the moisture and impurities, usually UK has a lower than POME. So if we are trying the raw POME versus raw UCO, it means that the content of the triglyceride or the oil is usually higher in the UCO. That's why UCO have the advantage on that. But POME has a higher free fatty acid content. So if we are comparing the triglyceride and also fatty acid, the fatty acid will provide a higher yield compared to triglyceride. That's why it will be quite balanced between POME and UCO. POME has the advantage on the higher FFA content, while UCO has the advantage on the lower moisture and impurities content.
I think, yeah, surely given the way the market is happening, we need all feedstocks, right? Both UCO and POME, right?
That's it.
Another one is also related, a bit commercial. This idea of blockchain is very fascinating. Is there any additional cost, significant or not? Do you have some numbers to share?
Now, in terms of the, if we talk about the capex requirement, that will be maybe later on will be put into the additional cost for the product. It's not really significant because it will be for the. I think the pessimistic number will be 1-digit million, so it will be less than 10 million. Well, obviously we know the capex even for the smaller sub plant will be more than 200 million USD. That's why I think it will be less significant and not necessarily adding the cost of the SAF that we produce from a blockchain-based system.
Okay, thank you for that. I'm going to bring in all the speakers as well, but there's one more question as well related. Will you suggest fuel marking, authentication to deter so-called greenwashing or to identify the fuel blend percentage? We have technical questions, but I'm sure you all look at this as an option.
No, I think that's obviously. I think in terms of to prevent greenwashing and also identify the fuel blends. That's why I think we are also trying to do this traceability system. So it also covers not only the feedstock but also the product. And so the end consumer will also able to see the transparent data, everything. They can even trace to what the plant level, mill level, and obviously to the sub plant level. So obviously this is something that we also want to help to prevent the greenwashing and also the fraud mixing. That's why we are trying with our partner to develop this traceability system.
Great. There's a couple of questions that are quite related. So I think we keep the floor open. Cyril, anything for us? Anything last thoughts on this topic? Both of you guys are working on trying to activate supply chains and increase the viability of the whole SAF ecosystem. What's your outlook for 2026 before we go?
I think starting from my side, Cyril, so for me, I guess we need to look at a different way to develop this project. Obviously, Tripatra also coming very closely from the oil and gas background, right? So I think we are quite common for the industry to see like we are trying to do as big as we could to ensure that we will pass the economic of scale. But again, SAF is a different ballgame. So we are trying to look at a different way because the feedstock is not coming directly from one industry. So we cannot take like big chunk of volume from one location. So obviously logistics will be a very, very big part of it, and also the security of the feedstock is something that we need to ensure. That's why we in Tripatra trying to look at a different way. So we are developing not really big, even we can say a small to medium scale plant, but we can have a more secure feedstock. We can have a more robust logistics. That's why that we ensure that it is able to moving forward to reach the FID and also to do the COD. Because we see that many projects trying to we can say very ambitious, going big, but very difficult to secure the feedstock required, and they cannot move forward. So this is something that we want to see from we see that from industry. They are trying to change the perspective from the big to the more small, but it's robust and also secure.
Great. I think we need more speed and action, right? Yeah, before we scale up further. Cyril as well. Can you chime in?
Great. it was music to my ear, right? And then what I've been advocating for some time now, if we want to enable companies like Tripatra to actually do something, but they need to know where is the feedstock. And so you guys are strong on localizing where is this POME today. But if you need some information on another type of feedstock, it needs to be available, but not a theoretical potential value. It needs to be something that you can securize, something that you can access, and something that you can transport at a reasonable cost. And this, there is a lot of understanding and work that needs to be put in there to have the data available for everybody to start to scratch their head on what kind of business case they can create around this.
Thank you for that. Excellent. I think we had almost glitch-free first webinar. I really want to thank the audiences for giving the questions coming in. The recording will be made available because I think we saw a huge turnout today, 100 over people, but we also had almost 300 people sign up. We're really trying to accelerate things here in Asia Pacific here at SAF, and we really like to thank Cyril and Faraz again for the time and energy today to prepare for this, and the rest of the team as well. And progress.
Yeah, no, just thanks to the two speakers, and thanks, my friends, for joining. I mean, it was really good to have you today, sharing and answering all the questions. I just want to give to say to everybody, okay, let's catch up. The next official events from our side are during the Singapore Air Show. We're going to have 2 events, plus we're going to be on site. We're going to attend some events, also side events that are not ours. So hope to catch up with all of you. Okay, we are growing. SAF is growing in the region. SAF is growing alongside with its member and its partners. So yeah, looking for the next engagement with you guys, and for the one not based in the region that I won't be able to join for Singapore Air Show, then join our next seminar, our next webinar in 3 weeks from now on, right? So and again, in the meantime, any question you might have or any connection you might want with Faraz and Cyril, don't hesitate, write to us. You have our website, you have some email addresses, and we make sure that our SAFA's team is answering to your questions, maybe not on the exact date, but as soon as possible. Thank you very much, everybody.
Thank you, everyone. Thank you.
Bye, guys. See you soon.
Bye-bye.